Hello, welcome to Fundamentals of Acoustics. Today is the second day of the 7th week of this course, and what we plan to discuss is continue our discussion on interference pattern as they emanate from multiple sources. So, yesterday we had discussed how sound waves constructively and destructively interfere when there are two sources separated by some distance d. What we plan to do today is we will revisit that discussion with a somewhat simplified assumption, with an additional assumption, and we will again develop the relation for two sources, and then maybe today as well as tomorrow and day after tomorrow we will develop relations for 4, 6 and then finally n sources. And when we have n sources, then using that information we will be able to figure out that suppose you have a string and it is emitting some sound source, and if the string is vibrating uniformly at all points, then what kind of sound patterns we can expect. So, with that we will start our discussion. So, interference from multiple sources. Okay. So, suppose I have two sources. So, I will again start the discussion using two sources. So, that is R1, that is R2. I am interested in finding pressure at point P, which is distance R away. So, that is my median, this is my median line, the horizontal line. The distance from the median line to point P is R, and this distance is d over 2 and this distance d over 2. The two sources are S1, S2, and the volume velocity for S1 is VV1 and its magnitude is such it is equal to VV. Similarly, for S2 we have VV2 and its magnitude is equal to again VV. But here we make one additional assumption which makes things relatively simple, and that is the phase of VV2 minus that of VV1 is 0. So, earlier we had assumed that it is phi, but here it is 0, and the second thing is R is still very large compared to the distance between two sources. So, with that understanding we will develop our expression one more time and offer it in a somewhat different form. It will be the same result or similar result. So, pressure at r theta t is equal to Vv times j omega rho naught divided by 4 pi r E j omega t minus r over c, and in the brackets what we get is E minus j d sin theta divided by 2c times omega plus E plus j d sin theta divided by 2c times omega. Okay. So, when the phase difference was phi, then there was also an e to the power of j phi in both these terms, but that has gone away. So, now we say that omega over 2c is equal to pi over lambda, okay, and we call this entire expression as A. So, my pressure or complex pressure equals A times exponent to the power of minus j, and omega over 2c is pi over lambda. So, j d pi over lambda sin theta plus E d pi over lambda sin theta, and then of course there is a j here and there is a j here. Okay. Yeah. So, now what we do is we define this thing as alpha. So, this is equal to A e to the power of minus j alpha plus e to the power of plus j alpha. Okay. And the next thing is I take this expression and in the parenthesis I have e to the power of j alpha plus e to the power of minus j alpha, and then I do a mathematical operation on this. So, what I do is I multiply it by e to the power of j alpha minus e to the power of minus j alpha, and I divide it by the same thing, e to the power of j alpha minus e to the power of minus j alpha. Okay. So, what do I get? In the numerator, what I get is, so when I multiply e to the power of j alpha by e to the power of j alpha, I get e to the power of 2j alpha. I also get e to the power of minus 2j alpha. So, this is one thing I get, and then when I multiply e to the power of j alpha with this guy, so I get 1, and when I multiply minus e to the power of minus j alpha with e to the power of j alpha, I get minus 1. Okay. And in the denominator, e to the power of j alpha minus e to the power of minus j alpha is 2j sin alpha, and the numerator becomes 2a j sin 2 alpha, and in the denominator I have 2j sin alpha. Okay. So, P of r theta t, oh, okay. So, when I was doing this multiplication, this thing should be a negative sign, because when I multiply this with this, I get the first expression, and when I multiply this term with this term, I get the second expression, and there is a negative sign there. So, 2j cancel out, and essentially I am left with a sine of 2 alpha divided by sine of alpha. So, if I have two sources, my pressure at a far field point is a times sine of 2 alpha divided by sine of alpha. So, thank you and have a great day. Bye.